Hi class, this lab is about drug delivery in a tank. We are going to model this process in COMSOL. As you see, I have already started COMSOL, and in this video I will go through the steps of the modeling. First, we are going to set up the model. In the Model Wizard, select 2D on the Select Space Dimension page. Click Next. In the Add Physics tree, select Chemical Species Transport of diluted species. Click Add Selected. Click Next. Find the Studies subsection. In the tree, select Preset Studies Time Dependent. Click Finish. Save this file in your N drive and name it diffusion.mph. Now we are going to enter the parameters. Global Definitions Parameters. In the Model Builder window, right-click Global Definitions and choose Parameters. Go to the Settings window for Parameters. Locate the Parameters section, enter the data provided in Table 1. First parameter dr is the diffusion coefficient in layer 1, 8e-19, which has the unit of square meter per second. Unit is not necessary here, but is strongly recommended. dp is the diffusion coefficient in a second layer with the same unit. mp is the number of nanoparticles, which has no unit. Vol is the volume of the tank. Kc is the mass transfer coefficient, 0.15 meter per second. Ca0 is 20 mole per cubic meter. And r is the radius. COMSOL is case sensitive, so be careful when you are entering your parameters here. You have to use the parameters later in the model in the same way that you have already defined it here. Now we are going to set up the geometry. Geometry 1. In the Model Builder window, click Model 1, Geometry 1. Go to the Settings window for Geometry. Locate the Units section. From the Length unit list, choose M. As you see, this is already the default here. Circle 1. Right-click Model 1, Geometry 1, and choose Circle. Go to the Settings window for Circle. Locate the Size and Shape section. In the Radius Edit field, type 1e-8. In the Position Edit field, set Base at Center. Click the Build All button. Repeat steps 1 through 5 and type R in the Radius Edit field. So we are going to add the second circle here. Build All. Click the Zoom Extents button on the graphic toolbar. Circle 3. Repeat steps 1 through 5 under Circle 1. So we are going to add another circle which has the radius of 1e-8. Build All. Save the file. Difference 1. In the Model Builder window, right-click Geometry 1 and choose Boolean Operations Difference. Select the object C2 only. Go to the Settings window for Difference. Locate the Difference section. Under Objects to Subtract, click Activate Selection. Select the object C1 only. So if you add this one, you will see that this is C3 and this is not what we are looking for. So maybe what you want to do is that hide this one and then add the circle behind this. As you see here, this is C1. And then you can just reset hiding and everything back to normal. Click the Build Selected button. Now we have set up the geometry. We are going to add another model to the system. A specification of the macroscopic OD model, Model 2. In the Model Wizard window, right-click Diffusion MPH and select Add Model. Select 1D on the Select Space Dimension page. Click Next. In the Add Physics tree, select Mathematics Coefficients from PDEC. Click Add Selected. Click Next. Find the Studies subsection. In the tree, select Preset Studies Time Dependent. Select Replace Study 1 from Add Study drop-down list. Click Finish. Geometry 2. In the Model Builder window, click Geometry 2. Go to the Settings window for Geometry. Locate the Units section. From the Length Unit list, choose M. Interval 1. Right-click Model 2, Geometry 2 and choose Interval. Go to the Settings window for Interval. Under the window, select 1 in the Number of Intervals field. Enter -0.35 in the left endpoint and 0.65 in the right endpoint edit field. Click the Build All button. In the next step, we are going to couple these models. Model couplings. Model 1. Right-click Model 1 Definitions. Select Model Couplings General Extrusion. In the General Extrusion window, locate Source Selection window. Select Point from the drop-down list of the geometric entity level. Select Point 1 from Circle 2 and add. Select the checkbox beside Use Source Map under the Source section and clear all the default entries in the Destination Map and Source selection. Model 2. Right-click Model 2 Definitions. Select Model Couplings General Extrusion. In the General Extrusion window, locate Source Selection window. Select Domain from the drop-down list of the geometric entity level. Select the interval from Geometry 2 and click Add. Locate destination map and enter Y in the X expression field. Locate the source section. Select the checkbox beside Use Source Map and enter X in the X expression field. Variables definition. Variable 1. Right-click Model 1 Definitions and select Variables. Go to the Settings window for Variables. Locate the Geometric Entity Selection section. Select Point and select Point 1 from the Circle 2 and then Add. Locate the Variables section and enter extra CPL underscore source underscore C under the Name column. And C under Expression column. Variable 2. Right-click Model 2 Definitions and select Variables. Go to the Settings window for Variables. Locate the Geometric Entity selection and select Domain. Go to the Graphic window and select the line and click Add. Locate the Variables section and enter C under the Name column. And mode1.gnext1 under Expression column. mode1.genext1 and in the brackets we have extra CPL underscore source underscore C. On the next row, enter extra CPL underscore source underscore U in the Name column. And U under Expression column. Variable 3. Right-click Model 1 Definitions and select Variables. Go to the Settings window for Variables. Locate the Geometric Entity selection and select Boundary. From the drop-down list, select all 4 boundaries on Circle 2. Locate the Variables section and enter U under the Name column. And mode2.gnext2 and in the brackets we have extra CPL underscore source underscore U. Transport of diluted species. In the Model Builder window, click Model 1 Transport of diluted species. Go to the Settings window for Transport of diluted species. Locate the interface on the Identifier section and replace CHDS with DI. Diffusion. Locate the Domain Selection section. From the selection list, choose All Domains. Locate the Transport Mechanism section and remove the check mark beside Convection. Diffusion 1. In the Model Builder window, expand the Transport of diluted species node and then click Diffusion. Go to the Settings window for Diffusion. Locate the Domain selection and select Domain 2 Graphics window. In here, these two are not activated, so later we are going to override one of these. So if you cannot delete one of these domains, is not important. Locate the diffusion section and enter DR in the DC edit field. So here we are going to add this diffusion coefficient. Diffusion 2. In the Model Builder window, right-click Transport of diluted species node and add diffusion. Go to the Settings window for diffusion. Locate the domain selection and select domain 1. So in here we are going to override domain 1 that we already defined in the previous step. Locate the diffusion section and enter DP in the DC edit field. Now we are going to set up the initial values. Click Initial Values 1 and ensure that it is only domain 2 that is selected. So in here again you cannot select any domain, but we are going to override it later. Go to the Setting window for Initial Values. Locate the Initial Values section and enter CA0 in the Concentration Edit field. Flux 1. In the Model Builder window, right-click the Transport of diluted species node and then select Flux. Go to the Settings window for Flux, locate the Boundary Selection section, and select all the outer boundaries on the outer circle in the Graphics window. Locate the Inward Flux section and check the box beside the species C and enter negative Kc multiplied by C minus U in N0C edit field. So in here we have minus Kc multiplied by C minus U. Initial values 2. In the Model Builder window, right-click the Transport of diluted species node and select Initial Values. Click Initial Values 2 and ensure that it is only domain 1 that is selected. Go to the Settings window for Initial Values. Locate the Initial Values section and enter 0 in the Concentration Edit field. As you see here, this is the default here, so we don't need to change it. Save your file. Now we are going to set Model 2, PDC. In the Model Builder window, locate Model 2 PDC. In the Settings window for PD, locate Units. From the Dependent Variable Quantity list, choose Concentration. So here we are going to choose concentration with this specific unit, which is mole per cubic meter. From the source term quantity list, choose reaction rate. Again, for the reaction rate, the dimensions should be consistent. So this is the units. Expand Model 2 PDC and click Coefficients from PD1. In the Settings window for Coefficient from PD, locate Diffusion Coefficient. And enter 0 in the C Edit field. Enter 0 in the A Edit field. Under Absorption Coefficient. For the F Edit field, we are going to enter NP multiplied by 4 multiplied by P multiplied by square of radius multiplied by KC multiplied by C minus U over volume. And 1 in dA Edit field under Damping of Mass Coefficient. Initial values 1. In the Model Builder window, locate Model 2 PDC. Expand the PDC node and then select Initial Values. Go to the Settings window for Initial Values. Locate the Initial Values section and ensure that the values present in the U and du over dt edit fields are zeros. Save your file. Now the model and the geometry is ready and we are going to set up the mesh. In the Model Builder window, click Model 1, Mesh 1. Go to the Settings window for Mesh. Locate the Mesh Settings section. From the element size, choose Fine. Right-click Model 1, Mesh 1 and choose Edit Physics-Induced Sequence. Size. In the Model Builder window, click Size. Go to the Settings window for Size. Locate the Element Size section. Click the Custom button. Locate the element size parameters. Select the maximum element size. In the associated edit field, type 3E-9. Select the minimum element size. Type 3E-11. Click the Build All button. Size 1. In the Model Builder window, right-click Free Triangular 1 and choose Size. Go to the Settings window for Size. Locate the Element Size section. From the predefined list, choose Normal. Click the Build All button. Now the mesh is ready and we can compute the model. The Study 1. In the Model Builder window, expand the Study 1 node and then click Step 1 Time Dependent. Go to the Settings window for Time Dependent. Locate the Study Settings section. In the Times Edit field, type Range from 0 to 1000 with the step size of 0.1. Locate the Physics Selection section and click the tick mark in front of PDC to deactivate this physics. So right now we are going to decouple these two models from each other, and first we are going to study the models that are decoupled. So at this point, the models are not coupled to each other. In the Model Builder window, right-click Study 1 and choose Compute. So for the task part, we are going to decouple these two and we are going to study the models that are decoupled. But for the exercise part, you are going to couple these two models and you are going to study that specific model. And as see here, the model is computing. If the computing of the model is really time consuming, what you can do is that you can increase the step size in the study. So right now the step size is equal to 0.1 and we are calculating the model from 0 to 1000. So if you increase the step size to 0.5 or 0.2, then the calculation time will be less. Okay, right now you can see the model. The default plot shows the concentration distribution on the surface of the drug particle. Once you have this model ready and there is no error or anything surprising you, so you can go to the task part, and once you have done the task, you can go through the exercises. Good luck, class.